Hello dear students, today we are going to discuss about pile of plates and polarization by double refraction from the chapter Wave Optics. The chapter name is Wave Optics. The topics now we are going to discuss now are pile of plates and polarization by double refraction. Polarization by double refraction. Right. We know that there are different methods is used to produce plane polarized light. You know what is meant by plane polarized light? The light which contains only one vibration in it is known as polarized light or plane polarized light. Polarized light or plane polarized light. Right. Generally, the plane polarized light is represented by like this, right? So both are plane polarized light, right? So what is meant by plane polarized light? The light which contains vibration in only one direction. Okay, the light which contains vibration in only one direction, then the light is called polarized light or otherwise called plane polarized light. Plane polarized light. Here both the diagram represents plane polarized light. Okay, then what is the difference between these two diagrams? Okay, simple. In this diagram shows the plane polarized light which contains vibration in only one direction. In which direction? Perpendicular to the plane of the board. Okay, the light which containing vibration in only one direction, but it should be perpendicular to the plane of the paper or perpendicular to the plane of the board is represented by like this. Right. And the second diagram also represent a plane polarized light. Okay, the only difference is that this light also consists of vibration in only one direction, but that direction is parallel to the plane of the board. Parallel to the plane of the board. So this is a difference between this diagram and this diagram, right? So but both the diagram represents a plane polarized light. But in this light, the vibration is perpendicular to the plane of the board, whereas in this diagram the vibration is parallel to the plane of the board. Parallel to the plane of the board. So both of them are plane polarized light, right? There are different methods are used to produce plane polarized light. Okay, what are the different methods? Right, first one, polarization by reflection. Polarization by reflection. Second, polarization by refraction. Polarization by refraction. Third, polarization by a double refraction. Double refraction. And fourth one, polarization by selective absorption. Selective absorption. And last one, polarization by scattering. Polarization by scattering. So these are the methods is used to produce a plane polarized light. Okay, unpolarized light is represented by like this. Or right. So these two diagram represents unpolarized light. Okay. So in this light, okay, the vibration is occur in all possible direction. Okay, the vibration in light occurs in all possible direction. Then the light is called unpolarized light. The unpolarized light is represented by like this or otherwise. Okay, this one. But these two diagram represent plane polarized light. Why? Because in this light there is only one direction. I mean, vibration occurs in only one direction. The vibration is perpendicular to the plane of the board, then the polarized light is represented by like this. If the vibration is parallel to the plane of the board, then the plane polarized light is represented by like this. But these two are represent unpolarized light. Okay, in this light, the vibration is occurring all direction, right? You know that what is meant by polarization? Okay, polarization means it is one of the phenomenon. The phenomenon of restricting of a vibration into a particular plane is known as a polarization. Okay, the vibration in this unpolarized light, we can restrict the vibration in only one direction. Okay, that phenomenon is known as polarization, right? So there are different methods of producing plane polarized light. They are polarization by reflection, polarization by refraction, polarization by double refraction, polarization by selective absorption, and polarization by scattering, right? Okay, there is a simple experimental arrangement which is used to produce a plane polarized light. Plane polarized light. Okay. That construction, the construction of that experimental arrangement is based on polarization by reflection. Polarization by reflection. Okay, that experimental arrangement is called pile of plates. Pile of plates. So, pile of plates is a simple experimental arrangement. Its construction is based on polarization by reflection. Polarization by reflection. Then, what is the use of this experimental arrangement to produce a plane polarized light? Okay, already I told you what is meant by plane polarized light. Plane polarized light is nothing but the light which contains vibration in only one direction is known as a plane polarized light. The plane polarized light can be produced by using this simple experimental arrangement. The name of the experimental arrangement, pile of plates. Pile of plate. Its construction is based on polarization by reflection. Polarization by reflection. Now we go for the construction of pile of plates. Right. The experimental arrangement consists of a large number of glass plates. So these are glass plates. Okay, they are placed one over the other. The glass plates are placed one over the other inside the tube. Inside the tube. So this is a tube. So these are glass plates. Glass plates. Okay, so there are a large number of glass plates which are placed one over the other inside the shootable size of the tube. Shootable size of the tube, right? And these glass plates are inclined at an angle of 33.7 degree. The glass plates are inclined at an angle of 33.7 degree with respect to the axis of the tube. So this is the axis of the tube. Okay, with respect to the axis of the tube, the glass plates are inclined at an angle of 33.7 degree. So, the pile of plates consists of a large number of glass plates which are placed one over the other, okay, inside the shootable size of the tube, which are inclined at an angle of 33.7 degree with the axis of the tube. The axis of the tube, right? Okay, now an unpolarized light. Okay, already I told. These two diagrams represent unpolarized light. Now, an unpolarized light is made to fall on the pile of plates or made to fall on the glass plates. Okay, so that the angle of incidence is 56.3 degree. Okay, if the glass plates are inclined at an angle of 33.7 degree, the unpolarized light is made to fall on those plates so that the angle of incidence will become 56.3 degree. Okay, 56.3 degree is polarizing angle for glass. Okay, what do you mean by polarizing angle? What is meant by polarizing angle? The angle of incidence of the unpolarized light for which the reflected light is a completely plane polarized light is known as polarizing angle. The angle of incidence of the unpolarized light on any surface, okay, so that the reflected beam is a completely plane polarized light. Okay, completely plane polarized is known as a polarizing angle. For glass, the polarizing angle is 56.3 degree. 56.3 degree. Okay, to get this much amount of a polarizing angle, the glass plate should be inclined at an angle of 33.7 degree with respect to the axis of the tube. Right now, this unpolarized light is exactly passes through the axis of the tube, and it is made to fall on the pile of plate, that is the glass plates. Okay, so that the angle of incidence become 56.3 degree, which is polarizing angle for glass. Polarizing angle for glass, right? Okay, here in this, unpolarized light, the vibration is occur in all direction. Okay, here the double arrow represent the vibration is parallel to the plane of incidence or parallel to the plane of the board, parallel to the plane of the board, and the circle represent the vibration is perpendicular to the plane of the board, perpendicular to the plane of the board. So for our convenience, we consider the vibration in two direction only. Okay, that is one is a parallel direction and another one is a perpendicular direction. Okay, actually this light consists of vibration in all direction. For simplicity, we consider only two direction, two vibration direction, two. So one is a parallel direction and another one is a perpendicular direction, right? When this unpolarized light is made to fall on this glass plate, the vibration which are perpendicular to the plane of incidence, perpendicular to the plane of incidence or gets reflected along this direction, right? Here in this light, the vibration consists of both the parallel direction and also perpendicular direction. The vibration which are perpendicular to the plane of the board or plane of incident gets reflected from each surface of the glass plate, each surface of the glass plate. Whereas the vibration which are parallel to the plane of incident or vibration which are parallel to the plane of the board, is transmitted through the glass plate and comes out like this. Understand? Right? When unpolarized light is exactly passes through the axis of the tube, and when it is made to fall on the glass plates, the vibration perpendicular to the plane of the incident gets reflected from each surface of the glass plate, whereas the vibration parallel to the plane of the incident is transmitted out. Right? Here this reflected beam is completely plane polarized. So these are plane polarized lights. Okay, here the unpolarized light is completely completely converted into plane polarized light with the help of this experimental arrangement. The name of the experimental arrangement, pile of plates. Its construction is based on polarization by reflection, because in this diagram the reflected beam is completely plane polarized. Okay, reflected beam is completely plane polarized light. Okay, in this beam or in this light, the vibration is occur in only one direction. Which direction? Perpendicular to the plane of the board. Okay, the reflected beam alone completely plane polarized. Okay, but with the help of this experimental arrangement. Okay, so that is why already I told this construction is based on polarization by reflection. Polarization by reflection is one of the simplest method to produce plane polarized light. Okay, this is unpolarized light, but this is polarized light. Okay, polarized light is produced by using this experimental arrangement. Okay, on the basis of polarization by reflection method. Okay, this experimental arrangement is called pile of plates. Okay, which is used to produce plane polarized light. Okay, and this pile of plates can be used as both the polarizer and also analyzer. Okay, pile of plates are used as both the polarizer and also analyzer. What is polarizer and what is the analyzer? A device which is used to produce a plane polarized light is called polarizer. A device which is used to produce a plane polarized light is called polarizer. So pile of plates is one of the example for polarizer, because which is used to produce a plane polarized light. Okay, and it is also acts as analyzer. What is meant by analyzer? A device which is used to analyze whether the light is plane polarized or not. Okay, whether the light is polarized or not. Okay, the name of the device is called analyzer. Here, pile of plates is used for both the polarizer and also analyzer. So, pile of plates is an arrangement which is used to produce plane polarized light. Its construction is based on polarization by reflection. Okay, its experimental arrangement consists of a large number of glass plates. They are placed one over the other inside the suitable size of the tube. And these glass plates are inclined at an angle of 33.7 degree. Okay, the glass plate is inclined at an angle of 33.7 degree. 33.7 degree with respect to the axis of the tube. Okay, 56.3 degree is polarizing angle for glass. Polarizing angle for glass. Now the reflected beam becomes completely plane polarized. The reflected beam becomes completely plane polarized. What is meant by polarizing angle? The angle of incidence at which the reflected beam is completely plane polarized is called polarizing angle. For glass, the polarizing angle is 56.3 degree. Right? Understand? And pile of plates can be used as both the polarizer and also analyzer. By using this device, we can produce a plane polarized light, or we can check whether the light is a plane polarized light or not. So this is a simple experimental arrangement which is used to produce a plane polarized light. Right. So far we discussed about pile of plates. Right. Pile of plates construction is based on polarization by reflection. Polarization by reflection is one of the method to produce a plane polarized light. Right. And next we go for another method of producing plane polarized light, that is polarization by double refraction. Polarization by double refraction. Right. First, what is meant by double refraction? Simple. When an unpolarized light is passes through some crystals like calcite, mica and quartz, there are two refracted rays are produced. Right? When unpolarized light is made to passes through some crystals like calcite or mica or quartz, there are two refracted rays are produced. Right? That phenomenon is known as a double refraction. Double refraction. There are two refracted rays we obtain. Okay, that is why that phenomenon is called double refraction. Right? And it was discovered by Bartholinius. Okay, a scientist Bartholinius discovered double refraction phenomenon from calcite crystal. Right? He was observed that when unpolarized light is made to pass through calcite crystal, there are two refracted rays are produced. That phenomenon is known as double refraction. It means if any object is viewed through either calcite crystal or mica crystal or quartz crystal, we can see two images of a single object. Two images of a single object. Okay, that means we can get to two refracted rays. Okay, one refracted ray produce one image and another refracted ray produce another image. So we can see two images of a single object. Two images of a single object. So that phenomenon is called double refraction. It was discovered by Bartholinius. Right? So what is meant by double refraction? When unpolarized light is passed through a calcite crystal, there are two refracted rays are produced. It means we can see two images of a single object. So that phenomenon is called double refraction. Right? And what are the crystals exhibit this double refraction phenomenon? Okay, first one calcite crystal, second mica and third quartz. So these are called double refracting crystals. Double refracting crystals. Right. Okay, now let us consider a single white sheet or white paper. Okay, on which we put a single ink drop or ink dot like this. Okay, this is a white paper on which there is a single ink dot. Right. If this ink dot is viewed through a calcite crystal, suppose which is stationary, the calcite crystal and white paper both are stationary. We can see two stationary images. Other two stationary images of the ink dot. Right. However, if the calcite crystal is rotated, if the calcite crystal is simply rotated, okay, now also we can see two images of the ink dot, but one image of the ink dot is moves and another image of the ink dot is stationary. Okay, so if the calcite crystal is rotated, one of the image is rotates and another image is stationary. Okay, or you understand? Right? So ink dot is made at the center of a white paper, and then that ink dot is viewed through a calcite crystal. viewed through a calcite crystal. Now the calcite crystal is gradually rotates. Okay, if the calcite crystal is rotates, there are two images of the ink dot we can see in. Among the two images of the ink dot, one image is rotates and another image is stationary. Okay, one image is always stationary and another image is rotates around the stationary image. Around the stationary image, right? So here this image is called ordinary image. The image which is stationary is called ordinary image. Ordinary image. This ordinary image is produced by one of the refracted ray which obeys laws of refraction. Which obeys the laws of refraction. That ray is called ordinary ray. Already I told, if unpolarized light is passed through a calcite crystal, there are two refracted rays are produced. There are two refracted rays are produced. One of the refracted ray is called ordinary ray. Ordinary ray. The ordinary ray obeys the laws of refraction. Ordinary ray obeys laws of refraction. And another refracted ray is called extraordinary ray. Another refracted ray is called extraordinary ray. See the diagram? So this is unpolarized light. This is calcite crystal. When the unpolarized light is made to fall on calcite crystal, there are two refracted rays are produced. Right? One of the refracted ray is called ordinary ray. Okay? This ordinary ray obeys all the laws of refraction. Okay, already you know about what is meant by laws of refraction, right? So the ray or one of the refracted ray which obeys the laws of refraction is called ordinary ray, right? And the refracted ray which does not obeys laws of refraction is called extraordinary ray, right? There are two refracted ray, one is ordinary ray and another one is extraordinary ray. The difference between these two, the ray which obeys the laws of refraction is called ordinary ray. The ray which does not obey the laws of refraction is called extraordinary ray. Extraordinary ray, right? Here, this ordinary ray produce the image which is stationary when if the calcite crystal is rotated. Okay, when the calcite crystal is rotated, there are two images of the ink dot can be seen. Among the two images of the ink dot, one image is always stationary and another image is rotates around the stationary image, right? So this stationary image is called ordinary image, which is produced by ordinary ray, which obeys laws of refraction, which obeys also laws of refraction, right? And the second rotating image is called extraordinary image. Extraordinary image, or simply we can say E image. So this is O image, right? The rotating image of the ink dot is called extraordinary image. Extraordinary image which is produced by another refracted ray is called extraordinary ray. Extraordinary ray which does not obey the laws of refraction. So this is a single ink dot. When the ink dot is viewed through a calcite crystal, there are two images of the ink dot can be seen. When the calcite crystal is rotated, one image is stationary, which is called ordinary image, which is produced by ordinary ray. Which ray is called ordinary ray? One of the refracted ray which obeys laws of refraction is called ordinary ray, which produces ordinary image, right? And another image is rotate around the ordinary image. Okay, that image is called extraordinary image, which is produced by another refracted ray is called extraordinary ray. Okay, extraordinary ray which does not obey the laws of refraction. Okay, that is, it means if any object is viewed through a calcite crystal, there are two images of a single object can be seen. Okay, there are two images of a single object is produced. One of the image is called ordinary image and another image is called extraordinary image. Okay, not only calcite crystal, mica crystal is also one of the example for a double refracting crystal. Quartz also one of the best example for double refracting crystal. Okay, so when the this is unpolarized light. So when unpolarized light is passed through the crystal like calcite or mica or quartz, there are two images of a single object is produced, right? One of the image is produced by one of the image is called ordinary image, which is produced by ordinary ray, which obeys the laws of refraction. And another image is called the extraordinary image, which is produced by extraordinary ray, which does not produce or which does not obeys laws of refraction, right? Now we go for the distinguish between ordinary ray and the extraordinary ray. Right? Okay, here inside the calcite crystal, the ordinary ray travels with the same velocity in all directions. Okay, if the ordinary ray is a travel in this direction or in this direction or in this direction, in all possible directions, the ordinary ray travels with the same velocity. Ordinary ray travels with the same velocity in all directions inside the double refracting crystal. Right? Whereas the extraordinary ray travels with a different velocity in different direction. If the extraordinary ray travels in this direction, its velocity is suppose v1. If it travels in this direction and its velocity becomes v2. And it travels in this direction, its velocity becomes v3. So inside the double refracting crystal, the extraordinary ray travels with different velocities. Whereas ordinary ray travels with the same velocity in all directions. Right? And next, inside the double refracting crystal, at one particular direction, both the ordinary ray and the extraordinary ray travels with the same velocity. Okay, only one direction inside the double refracting crystal. In that direction only, both the ordinary ray and the extraordinary ray travels with the same velocity. Okay, that direction is called optic axis of the crystal. Optic axis of the crystal. Okay, so all the crystal consists of optic axis. Right? What is meant by optic axis? Optic axis is nothing but a direction inside the double refracting crystal. What is the speciality in that direction? Okay, in that particular direction, ordinary ray and the extraordinary ray travels with the same velocity. Okay, so that direction is called optic axis of the crystal. So inside the double refracting crystal, at one particular direction, ordinary ray and the extraordinary ray travels with the same velocity. Such a direction is called optic axis of the crystal. Right? And next, suppose let us consider a point source inside the double refracting crystal. Point source inside the crystal means just there is suppose point source on which a crystal is placed. Crystal means either calcite or mica or quartz is placed. Now that point source behaves like inside the crystal. Okay, suppose let us consider a point source inside the crystal. Okay, and the ordinary image produces spherical wavefront. Ordinary ray produces spherical wavefront. So a point source inside the double refracting crystal produces spherical wavefront corresponding to ordinary ray. Okay, well, what is meant by spherical wavefront? Suppose a point source at a finite distance sends the light in all possible directions like this. Okay, so the wavefront corresponding to a point source which is at a finite distance is a spherical wavefront. So this is a spherical wavefront. Okay, here there are two refracted rays here. One of the ray is ordinary ray. Okay, the ordinary ray consists of a spherical wavefront like this. Okay, a point source inside the double refracting crystal produces spherical wavefront corresponding to ordinary ray, right? And a elliptical wavefront corresponding to extraordinary ray, right? So inside the double refracting crystal there is a point source. The point source produces a spherical wavefront corresponding to ordinary ray and elliptical wavefront corresponding to extraordinary ray, right? Okay, and already told along the optic axis of the crystal, both the ordinary ray and the extraordinary ray travels with the same velocity. In that direction, there is no double refraction takes place. No double refraction. No double refraction takes place inside the double refracting crystal. Where? Along the optic axis of the crystal. What happened along the optic axis of the crystal? If the unpolarized light is allowed, there is no double refraction takes place. That is, there is no two refracted rays. Okay. Other than this direction, if the unpolarized light is made to fall on this crystal, there are two refracted rays are produced. Except in this direction, remaining all other direction, there are two refracted rays we obtain, right? But along the optic axis of the crystal, no double refraction takes place. Why? Because both the ordinary ray and the extraordinary ray travels with the same velocity. Right? And one more thing, the refractive index of the crystal is the same for both the ordinary ray and the extraordinary ray along the optic axis of the crystal. Okay, if the refractive index value is measured either by using ordinary ray and extraordinary ray. If you use ordinary ray, suppose the refractive index of the calcite crystal is suppose mu1. If we use extraordinary ray, the refractive index of the same calcite crystal, suppose mu2. This mu1 value is equal to mu2. That is the refractive index of the calcite crystal, which is measured with the help of ordinary ray, is equal to the refractive index of the same calcite crystal, which is measured with the help of extraordinary ray. When this condition is applicable, only if the ordinary ray and the extraordinary ray travels along the optic axis of the crystal. Okay. Otherwise, the refractive index of the calcite crystal is which is measured with the help of ordinary ray is different from the refractive index of the calcite crystal, which is measured with the help of extraordinary ray. But only in the direction of optic axis, the refractive index of the calcite crystal is the same for both ordinary ray and extraordinary ray. Right? So this is for about double polarization by double refraction. Right? Here, actually, what will happen means, if the unpolarized light is passed through the calcite crystal, there are two refracted rays are produced. One is ordinary ray and another one is extraordinary ray. Here the extraordinary ray is completely plane polarized. But in the case of a pile of plates, the reflected light only plane polarized. The reflected light is completely plane polarized. So that is why the construction is based on polarization by reflection. But in this calcite crystal, double refraction takes place. Double refraction is also called by-refringence. Double refraction phenomenon is also called by-refringence. By means two. There are two refracted rays are produced, so that is why it is called by-refringence. Right? Okay, here the extraordinary ray is completely plane polarized. But in ordinary ray, which is completely plane polarized light, plane polarized means it consists of vibration in only one direction. That direction is perpendicular to the plane of the board. Whereas if the extraordinary ray is completely plane polarized means which contain vibration parallel to the plane of the board. Ordinary ray polarized means its vibration is perpendicular to the plane of the board. If extraordinary ray is completely polarized means which consists of vibration in only one direction, that is parallel to the plane of the board. Here the extraordinary ray is completely plane polarized. Okay, this method is called polarization by double refraction or polarization by reference. So once again I repeat, double refraction phenomenon was first discovered by Bartholinius. Right? He was discovered that when unpolarized light is passed through a calcite crystal, there are two refracted rays are produced. That is, two images of a single object is produced. That phenomenon is called double refraction. Right? If any object is viewed through a double refracting crystal, we can see two images of a single object. One of the image is called ordinary image. That image is produced by one of the refracted ray produced in the calcite crystal, which obeys the laws of refraction. That ray is called ordinary ray. And another image is called the extraordinary image, which is produced by another refracted ray which does not obey the laws of refraction. So that ray is called the extraordinary ray. Extraordinary ray, right? And ordinary ray is travels with the same velocity in all direction inside the double refracting crystal. But extraordinary ray travels with different velocities in different direction, right? And inside the a point source inside the double refracting crystal produces spherical wavefront. Spherical wavefront corresponding to ordinary ray, and the elliptical wavefront corresponding to extraordinary ray. In the case of ordinary ray, there is a spherical wavefront is produced. But in extraordinary ray, okay, elliptical wavefront is produced. Elliptical wavefront is produced, right? And next, inside the double refracting crystal, at one particular direction, both the ordinary ray and the extraordinary ray travels with the same velocity. Okay, that direction is called optic axis of the crystal. Optic axis of the crystal. Along the optic axis of the crystal, there is no double refraction. Okay, there is no double refraction because both the ordinary ray and the extraordinary ray travels with the same velocity. So no double refraction. Along this direction, the refractive index of the crystal is the same for both ordinary ray and extraordinary ray. Okay, so by using calcite crystal, mica crystal, quartz crystal, we can produce a plain polarized light. Okay, in which light consists of, which light is a completely polarized? Extraordinary light or extraordinary ray, which contains vibration in only one direction, but that is parallel to the plane of the paper or parallel to the plane of the board, right? So this is for about polarization by double refraction. So polarization by reflection, polarization by double refraction. So these are some simple methods is used to produce a plain polarized light, right? Thank you, students. We will see in the next class. Suppose if you have any doubt in this two topic, just you call me or some messages to my WhatsApp number, right? Thank you, students. We will see in the next class.